All right. Hi. Hi, my name is Nishay. Hi, I'm Nishay. So I've been a Solidity developer for around a year. So I came in the space like because of the money that you can make over here. I used to hold a lot of Bitcoin back in 2017, sold some of it, bought some of it, but mostly I lost a lot of money doing that. But then I became a developer. So I've worked in every aspect of like Web3, cryptocurrencies, DeFi, on-chain gaming. I've worked in Ethereum, Rust, which is basically Solana, and I've worked in Cosmos as well. So I'll just give you a small rundown of how I'm going to be conducting this. So what I'll do is I'll give you guys a very short introduction of what coding on the blockchain looks like, because it's very, very different. I'll give a little bit of theory because if you don't have that ground understanding, you won't really understand how to code on it. And then I'll take you through a very small example of how you actually code for Ethereum. Now, I'm not going to keep like a Q&A session afterwards. So if you have any questions, just ask me on the spot. Cool? All right.
Yeah.
Another thing would be, let's just talk about the simple prerequisites. If you are someone from CS, this should be easy for you. Because, well, if you've learned Java or C++ or even Go for that instance, these languages look very, very similar. But if you're someone who's learned like Python, then it's going to be a little bit difficult because Python is not a strongly typed language. And if you're someone who doesn't know coding at all, then I'm just sorry. It's going to be difficult for you guys. Apart from that, if you know networks, like how computers communicate with each other, how the TCP/IP, HTTP protocols work, that's a plus, but you don't really need to know everything about it. And this is just for the CS folks. Like if you guys know what public key cryptography is, what hashing algorithms are, how the blockchain works, how like consensus works, how like blockchains communicate with each other, and like what miners and validators are, it's good. But if you don't know any of it, it's fine. It just gives you a much more clear understanding when you code on top of these things. Finally, if all of you guys can just like Google what MetaMask is right now on your computers and get the extension downloaded. If you're already someone who's like interacted with the blockchain, you'll have it. But if you don't, just get that downloaded. It doesn't take more than a minute to set it up. And you need diamond hands because, well, if you don't really believe in the space, don't spend your time doing it because, well, it's a lot of effort. So coding on the blockchain. First, if you're someone who's coded a lot, you'll know almost instantaneously coding on the blockchain is just weird. So the first thing is, let's say all the people who don't understand what, let's say a simple client server model is, right? So this is just for the people, just a very small background. So you have all these clients, right? Either this is your computer, your mobile app, a Raspberry Pi, even your bulb, they all are clients that communicate to a particular server that is like running on some computer in some remote part of the world. And it does that through the internet, right? But with the blockchain, the server just goes away. So let's say if I'm making Facebook, right? I'll go to AWS, I'll ask them for the server, I'll put my code over there, and then I'll have like other people go to facebook.com and then they'll interact with my server that is there on AWS. But the problem with the blockchain is you don't know where your code is going to run from. The blockchain, if you guys have like seen decentralized networks before, are more like this. So there's no one central party controlling everything, which makes things very, very, very difficult when you're coding on top of it. It means no longer do you have control over anything. All you have to ensure is that you write good code and hope it works for the best. So with this, like if you guys know, have you guys interacted with the Ethereum or like Polygon or anything before? No? Okay. Yeah, I see a couple of people have, but not everyone. So let's say if you're doing something on like you're minting an NFT. Minting an NFT simply means you're going to a particular website and you're telling them, hey, listen, I want to buy this NFT. Every time you do that, you pay a certain fee for buying something, but at the same time for doing that action. So it's like if you're running a car, you pay for the gas to use the car, and at the same time you pay for the card itself. Got it? Yeah. So you have to pay for computation. You store a variable, you pay for it. You run a for loop, you pay for it. You call a function, you pay for it. Everything is in terms of money. Then there's also no concept of an API. So let's say the simple weather app I have on my phone will contact an API to get my location. Then we'll contact another API to get what the weather is for my location. You can't do that on the blockchain. The blockchain is like this gated community, and it can't really communicate with the world outside. Okay. Then another thing is that the blockchain is meant to be immutable, meaning that once something goes on there, it's never meant to change, never again, which makes it very difficult to change. So let's say I'm Facebook, okay, and I write some code, I put it on the blockchain, but I realize, hey, there's a small bug in this code. Now I can't just go back and change it. It's not easy. I have to write a new version of the code and deploy it somewhere else. Everyone can still interact with the old version, but I have to ask them to change everything from this old version to the new place. Lastly, it's also you have to be very secure while writing it. If you guys don't know, and you don't follow the news for cryptocurrency, this year alone, there has been $3 billion lost in funds, which is a massive, massive problem. So if you don't write good code, if you don't get security audits done, which by the way are just shit, okay? If you see an application or a dApp have a security audit, that doesn't mean it's good. Like I have done security audits myself, and the process is just to make money. It's not for anything else. There is no like trust or security involved in that aspect at all. There's also no randomness. Like you can't have like generate random numbers or anything like that. And the only one good side of this is that Solidity, the language that we will be doing, is Turing complete. Turing complete meaning that theoretically everything is possible, but since it's the blockchain, it has a lot of physical at the same time social limitations. You can't do everything. And the best way I like to think about it is that I'm a mechanic. I'm designing an engine. I'm always worried what happens if my engine fails. I'm always worried what if my engine is burning up too much gas. It's just a perpetual nightmare. A very good story I could give you is I was working with this company and they were always just worried about what would happen to their code. They were looking at transactions all the time to see what users were interacting with their code, if it's a malicious user, if it's not a malicious user, and try to differentiate between the both of them. But at the same time, there's a lot of reward for this as well. Some really nice things about it is that it's based on the concept of Legos. Like you've all used Legos before, right? You can just easily take a piece, use that piece, you can build up things on top of each other. So writing code on the blockchain is like that. Since its nature is in such a way that if all the code that he writes, I write, you write, all lives together, some third person can just come and build on top of us. So it makes it very, very easy to make new applications by using existing ones. Existing ones that anyone has made and you don't have to ask for permission for it. And yeah, if you guys already are familiar with applications like Convex Finance, Uniswap, Aave are examples of applications that will use other applications that are already on Ethereum. Then it's always live. As I said, it's difficult to update, meaning that your code will always be there as long as the blockchain survives. It can also make you very, 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 very rich. When I say very rich, I mean, I've worked with people who make over $1 million a month using their own protocols. And even if you're just a developer, like a simple blockchain developer, you can easily make over 150K a year. It's not that hard. And yeah, it's short and easy to maintain. That is, the code looks simple. Like I can show you the code for an ERC20 or simple cryptocurrency. It'll be less than 300 lines, but it'd be backed up by $50 billion in valuation. Uniswap, which is less than 2,000 lines of code, currently has done over $1 trillion in transactions. So just think about that. And yeah, lastly, what you're building is a smart contract using Solidity and not an application. That is an important difference. As I said, blockchains are severely limited in terms of its computation, the memory you can store on it, and what you can do with it. means that Facebook is not going to be a smart contract. Uniswap or any decentralized finance application can be a smart contract in where like two people are like involved in some way in a financial system, but you can't have Facebook, TikTok, or YouTube having all their data on the blockchain itself. It's just very expensive and there's no need for it. So does anybody have any questions up until now? Anyone? Awesome. So lastly, this is, if you're a CS student, you should already know about this, the concept of a compiler and a virtual machine. Are people familiar with that or no? Good. Does anybody need an explanation? Yeah. So a compiler simply is someone who, let's say I write code, right? But my code is not understood by all machines throughout the world. A compiler comes in, he takes my code and converts it into a language that can be understood by all the machines in the world. As simple as that. So that's all it is. Like very, very simple. If you've heard about like bytecode, assembly code, all of these things kind of mean the same thing. So there's this, I have a GitHub right now. You can just like go see that. How do I get it? Okay. So if you guys just want to open up this link here, can everyone see that? No. No. So it's github.com/NSH Madhani, MADHANI/Solidity workshop. Yeah, you just put it in Discord. I'll just put it in the general chat. If everyone already like is on the GitHub repo, then I can just like start teaching. Just let me know. So there's this link for something called as remix.ethereum.org. So you want to open that up and you should have like something like this. There'll be you don't need to do any of this. You should have something like this in your screen. Has everyone got it? Cool. So what you want to do is first delete these 3 files because you don't need them. And you want to create a new file. I'm just going to call, you can name it anything. It's called simple storage.sol. .sol is the file name for Solidity files. Once you do that, the first thing we need to tell is that we need to tell the compiler what version it's supposed to use. So with every version comes like new upgrades, it makes it more optimized or whatever. You can just write pragma solidity. I'll explain what this means. So this basically compiler 8.0 meaning use version 8. Pragma means what basically a Solidity, what language I'm supposed to use. You can write for EVM in like multiple different languages, and this is one way of just specifying what language you're using. Right? Forget this caret symbol that you see over here, it's not really of importance. Then what you can do is, what we need to create is simply a contract, right? Using this contract, what we're going to do is we're going to store something and then we're going to get that value back. It's a very simple introduction of how you code in this language. So let's just say contract, and I'm going to call it simple storage. And just curly brackets after that. Now, what you want to do is store some kind of data. Now, as I said, Solidity is strongly typed, meaning I'm storing any piece of data. I have to specify, hey, my data is of this particular data type. Is it an integer? Is it a string? Is it a byte? What is it? I have to also specify how many bits it's going to use. So if you guys used Java before, you know what an uint is. It's simply an unsigned integer. That means the values goes from 0 to whatever the limit you want it to be. So it can be 8, it can be 16, like 16 meaning 16 bits, 32 or whatever. But for our purposes, we're going to keep it very simple. We're going to call it a string. And string meaning that it can have any value possible. Like it can be has just 3, or it could also mean, hey, this my name is Nishay, blah 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 blah. Right? So I call it string, and we're just gonna call it answer. Just for now. Now, what you want to do is when you're interacting with this particular piece of code, you want to give it data. Now, for all the CS people out there, when you've written code before, what you've done is you've written the code before, you've gone to the terminal, you've specified, hey, compile this file and then run it, right? But blockchains and Solidity doesn't work like that. Yeah, sure, you could, but that's not the way you go about it. We're gonna first like add some things to it, and then we're gonna move forward with that. What you're gonna do is you're gonna create a constructor. Does everyone know what a constructor is? Like what classes are, what constructors are? Good. Anyone who needs an explanation? You? Okay, so think of it, what you're writing right now is a template, right? So when you're designing a car, you'll have one particular template where you'll say it has 4 wheels, it has one like driving stick, it has 4 seats or whatever, right? That's a template that you have for the car. You don't know what make and model of the car is. But when you create the car, when you're manufacturing it, you will say this car has the color red. It has blue seats or whatever, right? So what you're doing is you made a template over here of called simple storage. And now what you're going to do is you're going to instantiate or basically create or manufacture that card that is specific to you. So in this particular instance, you're going to tell it what will be stored within the template. What will be stored over here. So you're going to write string, memory, and I'll explain what these 3 things mean. String meaning I'm going to take a string as a constructor. This is basically you telling I'm going to color my card in the color red. Memory, okay. Everyone is familiar with what a hard drive is and what a RAM is, right? And the differences between the two. But if you guys don't know, RAM is it doesn't store your memory at all times. If you remove it from the electricity, it's just gone, the data is gone. While a hard drive will always keep your data. Memory over here refers to store the data for this within a RAM and not within the storage. The reason why you specify it is, again, the blockchain. You have to pay for everything, so you want the cheapest thing possible for you. Then underscore answer is the reason you add an underscore is because it's just the naming convention when you're writing with Solidity. You're trying to specify that this is only used as an internal variable within this particular block. It's not going to be used outside of that. And I'm just going to keep it simple at answer is equal to answer. This means I'm going to take the parameter and just store it as my global variable. Any questions? You look confused. Okay, good. Now, what you've done now is you've basically made the car, said it's the color red, but how do you see that? How do you go and see what is this color? Like what's the color of the car, whatever. So you create a function for that. We're going to call it function, simply get. This is an access modifier. Everyone is familiar with access modifiers? Yeah. So an access modifier basically tells you who can access it. Public meaning everyone. There are other access modifiers. There's public, private meaning only the code within these few lines can access it. Stuff like that. I'm going to write view. Now, view simply, you don't need to write what I'm writing in the after the slashes. Okay, like those are comments. State mutability. Okay. So in the blockchain, there's a very simple concept of something called as state mutability. Now, remember, anything you do on the blockchain will cost money. So if I'm just reading something from the blockchain, there's no money involved because you're not asking the person who you're taking the data from to like do any kind of expensive computation. You're simply reading from it and that's it. He just has to simply send you a couple of bytes and that's going to cost him like even fraction of a cent. But when you write something to the blockchain, that involves him doing work and you simply have to pay for that. Over here, we say it's a view function because we're simply reading data. We're not going to be writing anything to the blockchain. That creates a, like what we'll see later, but you're only seeing things, you're not writing anything to it. Now, so that's why you write view. But if you are writing something to the blockchain, you don't specify view. Then we have returns. You're simply specifying what type of data type I'm going to return. And you can write string memory. String memory again is like you're returning a string which will be in memory. I'm just going to write return. That's just the simplest way you can read the data from the blockchain, right? Now, those of you already know Solidity will know that you don't need to do this. You can come over here and like string answer and simply specify this as public, which tells everyone on the chain that, hey, people should be able to see this data very efficiently. That's it. Like I'll just show you guys later what this would actually do. But does everyone have MetaMask installed by now or no? You need a few minutes. Like, is it instantiated? You can see, like, you can interact with it or everything. Okay, cool. So now you want to go over here, like the fourth from the top. This is where you can run your code, right? This Ethereum icon over here. You can go here. This must have been already selected for you, and you will see about like what color? That's orange, and you'll see string answer. So you can just write whatever you want over here. Like, what do you think is the answer? Just write. For me, I'm going to write the answer, the meaning of light. Light is the, something along those lines. Just write what you think is the answer is, and then click on deploy. So if you will see if everything has worked out well for you guys, is that it'll create this thing where it says some random letters to simple storage constructor value 0. Can everyone see that? Right? So what it's done is it's created this local version of a very simple blockchain for you and deployed your code over there. Right? And you'll also be able to see your deployed contracts over here. Right? Can everyone see that? And if you click on this arrow over here, you'll be able to like see these two buttons. They're blue because you can read from them and you're not really like transacting with them. So you click on answer and you should be able to see what the value is over there. If you click on get, you should be able to see the value again over there. You're simply getting the variable from the blockchain. Got it? Now what we're going to try to do is we're going to try to write value to this and at the same time deploy it on an actual network. So I'm going to write a new function called function set. Now I'm going to set the value again. So I'm going to take again, I'm going to take a parameter so that I can set it. I'm going to call it public so that people interact with it. And I'm going to say answer equal answer. As simple as that. So this ensures that if someone calls this function from the outside, they can set a value that I want them to. Now, again, you can go over here, set a new value. Right? And I'm going to deploy it. Is everyone good with this or should I take pause for a minute? I'm going to deploy. And now you'll see another one over here. This is the new version of your contract. So as I said, your old version is still there. It's not been changed. It's always going to live. And what you've done is simply created a new version of the contract. Now you can go to this one if you click, and you'll see like a set and then well, some space to write your answer over here. So you can write whatever you want over here, and then you can call the set. You can just click on this. So previously what I'd done is the meaning of life was like to get money, right? That's what it was. But now if I click on answer, it says Nishay, fuck you. If I want to do something different, like I just like put someone's random name over here and I click set again. And now if I call answer, I can see there's a new value ascribed to it, right? So this was completely local. What you actually want to do is deploy this to an actual like live network, right? So those of you who already have MetaMask installed, the first thing you should do is go back to my GitHub. Can you guys see this link, faucet.to/Gorillai? You want to click that. And for now, just like click on the first thing available over here. And so in your MetaMask, it's going to open up something like this. You can see if you click on account 1, it'll copy the address that you have. You paste that over here. Complete this small little verification thing that you need. Oh, fuck off.
Are you sure you're not a robot?
Containing a doc. This is a doc, right?
Yeah.
Yeah. Cool. And then you just want to click on start mining. Just give it a couple of minutes and then just stop it. But I'll explain the reason that we're doing this. So, as I said, interacting with the blockchain costs money, right? Now you don't want to do it on an actual, like real live blockchain with real money. You know, do it on something of a test network where people like me can test on it and other people like the Ethereum developers themselves can like experiment on it, right? So what you need for that is you need actual like ETH for that test network too. And for those reasons, you have these community faucets that you're supposed to get that from. If this is taking too much time on your computers, you can just stop. There are other links over here as well, but I would recommend everyone right now to like get some test ETH. Like whatever it says, just do that and get some ETH on your computer. Okay. And once you're done with that, right? You can see if you see where it's called DMX VM London, click here, and you'll see injected provider, which means any network I select with MetaMask, like you'll have multiple options over here. The first one will be Ethereum mainnet, but you want to scroll down and select Gorillai test network. Any network I select here. So which makes it very simple for like people to deploy on Ethereum, Polygon, and all these other chains that you've heard about. And then once you're done with that, you can come here again and select, let's just say, right? And you click on deploy. You see, this is basically called signing a transaction. This is called signing a transaction. The reason that you have to do that is because if I am ready to put my money and deploy this transaction, I need to be able to pay for it, right? So it's telling me that it's going to cost me this much ETH, and this is simply the gas that I'm paying for creating the transaction. I click on confirm, and the transaction has now been sent. You can see this. So this is something called as Etherscan. Is everyone familiar with Etherscan? No, right? Everyone's good. So what's happening right now is there's this pool of transactions that are waiting to be confirmed. And my transaction is over here with that. So once it gets confirmed, that means my transaction, my contract will be on the live chain itself. The reason that previously it was instantaneous and now it's not. Is that now it's on an actual network run by like thousands and thousands of people, rather than being a very local environment that only one person is running. Right? Let me just wait for this. Yeah.
Can you go back like 2 steps? So
From where?
to like the testnet area. Just
To get the faucet part of it.
yes.
So, okay, so you mean from here, right?
Yeah.
So did you try the first thing?
Yes.
Did you get anything? Like, were you able to finish everything off?
I just entered in my wallet's
Address, right? And did you start the process? Was it like showing that it's mining anything?
yeah, it's mining something.
Yeah. Okay. So now just like stop mining,
Okay. Stop.
and it's gonna send you like some random amounts of ETH,
Okay,
and it's gonna just say how like did you click stop or no?
I did.
So are you back on this page again?
Yes.
Okay. So now what's happening is basically they send you some amount of ETH. I would just recommend opening MetaMask and checking this. And have you selected the Goerli network over here? Or no? Like if you click here,
No.
I have a bunch of options available to me, but that's just because I've done a lot. But you should be able to see ETH mainnet and then Goerli test network over here.
Okay.
Can you?
I wonder what we're thinking.
So just open MetaMask and you should be able to click here.
Let me see one. Oh, I had show test. Oh,
Yeah.
yeah, I can see it.
Yeah.
So just put that address in the faucet though? 'Cause
It will be the same address. It
Oh.
doesn't matter. So do you see any ETH over here? Does it say like I have like you have 0.01 ETH or whatever?
Say that a flat 0.
Then okay, you want to try a different link. Just go back to this page. And you see that Paradigm also has another link. Click on that.
I have to mine some like imaginary.
Yeah. Yeah. But over here, if you just like sign in with Twitter, you easily get it, like almost instantly. I can't do it because I've already done it once. Yeah, so you sign in. You can just click on claim, and yeah, that's it. The reason I don't show Paradigm is because, well, yeah. So is everyone on board with that? Getting faucet testnet ETH or no? Cool. Okay. So now we're already like seeing that my transaction is going through or not, and now it has been confirmed. So if I go here again, and I can see that I have this, you have a bunch of them, but I just have one. I should be able to set a new answer. So I'm just going to write some random strings, just some random thing. And I click on set, that is I'm changing the answer again. It's asking me to confirm the transaction because, again, I'm writing something to the blockchain. It's going to cost me money and I should be ready to pay for it. I click confirm. And you can see view on Etherscan, that means another transaction is going through. So now we have to wait for this to confirm. And while it'll take some time to show up over here, but it's almost probably done. And if I just wait for this to happen, you should be able to see that the data that you wrote on the blockchain has been done, and you should be able to see it now. And this, if you guys are familiar with like normal, like just writing a tweet, you'll know that this is a very tedious process. And that's why like blockchain and like Ethereum and everything is still in its infancy. So if I click on get, you can see whatever string I said over here basically comes out. So is everyone on board with this? So I can show you guys how to create like your own cryptocurrency now. Everyone's good? Okay. Just for like, just to show you guys what Etherscan is, if you go back to my GitHub page, you will see that I have some deployed code already over here. And if you click on that and you go into this tab for contract, you can read and write with it. So if you don't interact with your own contract, this is something that's already there. and you should be able to like interact with this as well. So you can get answer. You can connect like your wallet and then make transactions on top of this. Yeah. So now I'm just gonna try and show you guys how to create a simple ERC20 token. Who knows what an ERC20 is? Everyone? Okay, most people aren't familiar. So ERC20 is a standard for a simple token, right? Token meaning that I have 10 Bitcoins or he has 20 Bitcoins or whatever. So ERC20 is a standard for storing that information. That's it. Do you guys know what Shiba is? Yeah, obviously. So Shiba is an ERC20 token. If you guys have heard about, yeah, that's the only one I know right now. So yeah. What you can just create a new file, call it shitcoin. Right? And just like before, we're gonna make it we're gonna tell it what version of Solidity we're gonna use. And I'm gonna call it contract. And I'm gonna say just random. Right? So is everyone like good? So I'll just now this is a very important part. So you can name this any coin that you want. This is just something I've done for myself. The best part about like working in the blockchain space is that it's meant to be very open. Is that people are very eager to like share their code with you to write standard libraries that other people can build on top of. So what we'll be doing is we'll be using something called as Open Zeppelin to create our own ERC20. So why do we use Open Zeppelin? You can see they already have everything written out for us. Why do we use Open Zeppelin? The reason is that if I write code that is insecure, and if someone hacks it, people of like the users of my application will lose money. But the code written by Open Zeppelin has been tried and tested, and it's an industry standard. And if that gets hacked, then well, everybody is fucked, not just you. So it's much more easier for us to like depend on them because they write some of the most beautiful code I've ever seen. I think I already have the link that you're supposed to copy in the GitHub, but if I don't, I'll just update it. Okay, I don't have that, but if you guys can just Google Open Zeppelin ERC20. And you should be able to like come on this page as well. What you want to do is you want to just take this one line that says import add Open Zeppelin, just copy that, come here and paste that here. So what you're basically doing is you're telling, hey, listen, I'm going to be using the code written by these other people, and I want you to go fetch that and then compile my code, right? So how do we actually use it? Has everyone gotten that like one line of code or no? Right? Okay. So you just say is ERC20. Is that you're saying that my coin is also an ERC20 token. Then what you want to do is you don't have to write, you don't have to store anything, you don't have to do anything. Oh wait, before that, are you guys familiar with the concept of inheritance? Everyone knows what inheritance is, right? Okay. So think of it this way, right? We can have a general class called an animal. An animal breeds, excretes, mates, right? Those are its three functions, right? But you can have a human is also an animal. A dog is also an animal. At the same time, a dog is a wolf, and then a wolf is an animal, right? So you have a class, and then you have smaller subclasses. So you have one ERC20 as a standard, and then you have Shiba, RWA's tokens, Uniswap LP tokens, all are subclasses of that. So what I'm saying here is that NSH coin is kind of like the human and the animal example is an ERC20. So it has all the properties of an ERC20. It has all the code of an ERC20 token, and you don't have to do any kind of effort. Like you don't have to write any code for it. Just like before, I'll add a constructor. And what I'm doing over here is I'm calling ERC20. This basically tells you, hey, listen, remember ERC20 that I'm also a part of, also call that and give it some values. So I'm going to call it Nishay coin, and I'm going to give it, if you guys are familiar with the concept of tickers, so I'm just going to give it a ticker over here. And I'm going to call it a message. And that's it. That is literally how easy it can be to like create your cryptocurrency. So if you're going to like, ape into any cryptocurrencies at this point, you should be really thinking about it. So that's like 3 lines of code. That's it. It's almost effortless. Now, obviously, there is no use case for this. To actually make it used by other people, you have to create an application and all these Ponzi-nomics on top of that, so that people believe your fake idea. But no. Right. What we want to do is take this coin and give it to someone, right? Like so that people can start using it. So this is called a UN. I've already explained what that is. It's simply a number that goes from 0. It can only be a positive number. That's it. And I'm going to call it initial supply, right? And within the brackets, I'm going to write mint. Now, this mint is a function. It's a part of ERC20. I haven't written it. I haven't done any kind of efforts for it. And I'm going to say msg.sender. msg.sender simply implies whoever is making this transaction or sending this transaction, whoever is signing this transaction, that particular address should go over here. So if I make the transaction, it'll be my address. If he makes it his, or whoever makes it their transaction, their addresses would go there. And then I'm telling, give him those many amounts of tokens. So I'm going to call it init supply. So now whoever is creating the contract will get those many tokens directly given onto them right from the start. Okay. So go back to deploy. And you can see the contract will already be an SH coin or whatever thing you're working on. But if it's not, you can come here and change it. And now this is a concept for, like, it's a very simple concept, but in Solidity, in Ethereum, there is no concept of a floating point number. That is, you can't represent 3.14 or 1.79 or such kind of numbers. It can always just be whole numbers. And the reason for that is that every computer is different when it comes to handling these small or really like accuracies. And so that there's no dispute between different computers, you don't do that. You don't use floating points at all. You want to use a complete whole number. And for those reasons, you'll have like 1 ETH will be represented as another variable called wave, which will be like 10 raised to the power of 80. So there's something called as Etherscan's converter units. You don't need to understand it. If you want 1 token of something, you just write 1 over here and you copy this 10 raised to 18 value, because everything is in terms of decimals. 1 is also multiplied by 10 raised to 18. So I have 1 token means I have 10 raised to 18 tokens of it. But when you, in terms of saying, like when we are talking about it, we just use 1. And then I'm going to say, I want 10 of those. I click deploy, confirm, and just wait for that. Yeah, so while that happens, the transaction gets created. Does anyone have any like questions regarding this? Because this was a lot, all of it together. You?
Just a little curious, like, who is running the testnet? I know, like, it's all fake.
Yeah. So I am also running the testnet. Anyone can run the test. So the reason why they have a testnet is so that people who are like, so the concept of like you're already familiar with most things about Ethereum, right? Yeah. That's why you're asking that. So let's say someone wants to become a validator on it, right? But they're just starting out. Now they're not going to go directly and just start a node and ETH and start interacting with it. Because in that particular instance, you have financial incentives at play. And if you fuck up, you're fucked. Right? So people like me will go first, try it out on a testnet. They'll like get some fake ETH from all these different places that I showed you before, stake their ETH, get an actual computer to run everything, and then let that do its thing. Once they're confident enough, they'll then come up with their own validators for the main. So I'm doing the same thing right now. I have an AWS machine that's a validator for the testnet. And once I'm like good with that, me and my friends are gonna start opening up a mainnet validator. That's how it comes. Okay. But I think this transaction is done. So yeah, this is done. And if you can see, it actually shows that like the ERC token 20 token was transferred between from 0, meaning that it didn't go from anywhere. It just started out, it was just newly created to this particular address, which is my address, and what the coin is. And if you do this like perfectly, you should be able to see this as well. So yeah, that's that for my particular talk for right now. But I have a lot of like resources of how you can learn Solidity on your own. So if you go back to my GitHub page, you should see the resources here. Now, Crypto Zombies is the best. It's the most easiest way to learn how to code on Solidity, and that's how I did it as well. And it's a very playful environment. You have an actual storyline, you're writing code for that, and it builds up on top of it, like in a very slow and progressive manner. Apart from that, there is this really, really great YouTuber who works for Chainlink Labs called Patrick. And he has an in-depth 31-hour tutorial on how to be a Web3 developer. So if you guys are even more curious, just check that out. And lastly, if you guys want to go deep and become like a proper Solidity dev that can make a lot of money, then there's a couple of articles to understand Solidity in there. But yeah, that's my talk for today. If you guys have any questions, just ask me.
Yeah, so you have like 8 minutes left. Feel free, close the computers, come on down, ask questions.
He has a question actually, yeah.
Wait, sorry, you did the transfer function to get that in your wallet or?
So yeah, I'm gonna give you like a long answer for this, but like you should know about it. Technically, nothing comes to your wallet. Everything is on the blockchain, but it's associated with your name, right? And the transfer function you're talking about, like where I just got random amounts of my own coin, it's not the transfer function. It's the mint function, meaning I'm minting my tokens and I'm giving it to him. It's not really a transfer of something. Because it's not going from one person to another. It's just showing up randomly.
Wait, I guess my mint function doesn't show up like, is it supposed to show up like over here?
Right?
Like, is it supposed to show up here?
Okay, yeah.
Sorry, I
Yeah.
just like was wondering, I got lost.
Right. So his question was why this particular mint function does not show up over here. And the reason for that is you see this underscore that basically should tell you that it's an internal or a private function and people from outside can't access it. But if you do want to be able to like have this mint function, you can create a wrapper on top of that. So something like this, and then you can call it so. Now what you've done is you expose the internal mint function with like a public mint function anyone can access. So if you deploy this, you'll be able to see the mint function there over there. But that would also mean that anyone can just create their account. Yeah. But yeah.
I had a question about the access modifiers.
Okay.
When you write like public view,
Mhm.
does the view part of that actually have any implementation effects, or is it just for like readability, like best practices?
No, so it does have a very big implementation plan. So remember this, right? If you read something from the blockchain, simple, super simple, very cheap. But if you're writing something to the blockchain, it's gonna cost you money. So if you see over here, when I click on answer or like get, which is a function, but it's a view function, right? It's not asking me to sign a transaction. Because it's cheap, it's so cheap that the validators don't care about getting money for that, which is gonna send you the data for their efforts. But when you write something to the blockchain, it's gonna cost. So if you don't specify view over there, it's gonna ask you to sign a transaction and then give you your data. So you're gonna have to pay for like calling your data. So that's the big implementation.
But if you, but so let's say you call, you specify something as view and you try to write something in
Yeah.
that function, it won't let you do that.
So you could do that, but it's just gonna, the transaction is gonna pay every time you do it. Yeah, it won't let you do it. You can write code to do that, but it won't let you. Like that, yeah. Any other questions? I guess, yeah,
Yeah, awesome. Thank you guys for coming out. If you're not already, join the Discord, and then in like important links, you can press the computer. It'll auto sign you into the dev channel. So that's where devs, excuse me, that's where devs are most active, as well. If you have any questions, stuff like that. But thanks for coming out, guys. Have a wonderful rest of the day. Good luck on midterms if you have this week.
Thank you.